Hello, my name is Caireen Ryan. I'm a math coach with the Toronto District School Board. Today we'll do maybe a slightly different take on some familiar material. We're going to look at supporting students with expanding and factoring through a developmental approach to mathematics learning. First of all, I'd like to do the land acknowledgement. We acknowledge that we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. To start, I'd like to take a look at this quote, and it's from the new K-8 Ontario curriculum for mathematics. A mathematics curriculum acknowledges that the learning of mathematics is a dynamic, gradual, and continuous process, with each stage building on the last. So what we're going to do today is to look briefly at a very specific developmental trajectory in mathematics that originates in elementary with multiplicative thinking, specifically with the use of area models that demonstrate partial products, and then show up again in grades 9, 10, and 11, where students learn to expand using the distributive property and then factor by decomposition. Those are two key mathematical processes that students often encounter in a way that is primarily algorithmic. So one of the things that we want to do today is to talk about connecting new learning, to prior context, so that expanding and factoring can seem to our students to be meaningful extensions of prior learning and less like new and mysterious concepts that are dropped in. We know that when we can fit new learning into pre-existing frameworks and understand how and why we adjust those frameworks, better retention is possible. I was really interested in doing this session because I know as a secondary teacher, it's pretty rare that we look back at the elementary and middle curriculum and talk about how concepts originate in those early grades. But what we know about our students' prior learning can inform our next steps in a way that can help us to support all of the students in our room. Before we proceed, I'd just like you to try a minds on, if you have a moment to stop and try this, in how many different ways can you represent the process of multiplying two two-digit numbers? So for example, 24 times 35. Now there are all kinds of responses that you could get, and I'm not sure what you would get, but here are 4 common ones. The reason for doing a minds-on like this is that what we know about students' prior learning can inform our next steps and can also provide an opportunity to address some areas, where students might require review or even some additional skill building. One of the things I wanted to talk to you about today is selecting and sequencing responses. So there might be a couple different ways in which you could select and sequence these responses. One is in terms of a developmental trajectory. So I've done that here. The red one is an earlier type of thinking, followed by the green. The green pen represents something that students learn in grade 5, which is that the product of two two-digit numbers can be represented using an area model. And you can see the sum of the partial products below. And then students move on to the method shown in black, which is the algorithmic approach. And that's what we learned in elementary school, most likely, right? Where you carry the 1 and carry the 2, and you have to make sure that you put the 0 in down here in the second row. And just as an aside, it can be fun to ask students if they remember why the 0 has to go there, because sometimes that can open up the issue of what exactly is happening here. Because students are not supposed to use or learn to use this algorithm until they understand why multiplication works the way it does, as it is shown in green. Students may not provide a representation that looks like this partial products representation, and if they don't, that's totally okay. You can take student responses that are given and find a way to connect them to this. Because if I were going to sequence these responses for use in a lesson where we would be talking about the product of 2 binomials, I might do things differently. I might make this green one prominent. And this is the one we're going to spend a fair bit of time talking about. I just want to pause here for a moment and say that it's always worth it to dig deep into student thinking, as long as it's intentionally used to move learning forward. And this is why the pre-instructional assessment is so key. I've sequenced these in a particular way And I found that it's helpful to anticipate what you might see from students ahead of time so that you can be ready to sequence what you see, because all kinds of unexpected things may come your way. Or even better, you could invite students to group or sequence the responses for the purposes of the lesson. So I'm going to spend a couple of minutes taking a look at the very specific developmental continua that I talked about before. And they are actually not so much continua as leaps. There's one that begins in grade 4, where students represent and solve problems involving the multiplication of 2 or 3-digit numbers by 1-digit numbers, and they connect those two arrays. And then there isn't a lot that's new that's done with that until grade 9, where students multiply a polynomial by a monomial, and then they can represent that using a variety of tools. And of course, in order to do that, they have to be able to describe the relationship between algebraic and geometric representations in order to use those tools. In grade 5, students represent and solve problems involving the multiplication of two 2-digit whole numbers, and this is what we were looking at in the minds-on. Then, the next new thing that they do with that information is in grade 10, where they expand and simplify second-degree polynomial expressions using a variety of tools, and factor polynomial expressions. So that's quite a large amount of time that goes by between grades 4 and 5 and grades 9 and 10. So it can be really helpful for us to have this opportunity to give students, or to review with students, the conceptual framework that will inform the next steps. So as you can see, quite a bit of time goes by between the initial learning around multiplication and then the extensions to algebra. It's really important for differentiation to meet everyone where they're at and to move them toward the learning goal. So there are a few ways in which we can do that. We can spend some time with the conceptual underpinnings, so we can take a little bit of a look at the multiplication of 2-digit whole numbers, as we did in the minds-on. And then also what we can do is we can connect to manipulatives or visual models. And what we're going to look at today is the virtual manipulative that Matthews has. It's a virtual algebra tile manipulative. And just take a look at how that area model translates into what students will see if they're working with algebra tiles on quadratic trinomials. So one of the really fun things about the area models is that, well, I'll show you. So you see what's happening here. This is really the same moves as taking the product of two binomials, but it's done with whole numbers. Right? And you can see that the distributive property is being used. So if we start with this, oh, that was a lovely arrow. If we start with this as a transitional review piece, give students maybe even an opportunity to come up with their own and just try it with a friend and just make sure they know that it works and why it works, then it isn't much of a stretch to moving on to taking a look at the product of two binomials. So as you know, students typically learn to factor this kind of trinomial by splitting the middle. So they say to themselves, okay, well 2 times 12, well that's 24, and I have to find two factors of 24 that add up to the coefficient of the x term. So that's got to be 8 and 3, great, and so those are the coefficients of the terms that I will split the 11x into. Great, here we are. Oops, pardon me. And in the end, they factor by grouping, right? And done. The question that so many students tend to have, though, is why? Why do we do this? How does it work? Right? And we do explain it to them. I know that. But I think that in the context of where it comes from, with the multiplicative thinking, it is a lot easier to retain. So what I'm going to do is just, I know most of us have used algebra tiles, and I do want to just, as an aside, say a word about manipulatives, which is that it is really important to train students on the manipulatives so that they are able to use them. So what do each of the pieces mean, and how do they move, and that sort of thing. And I know that we know that. It's also important for students to understand why they are using a manipulative. So particularly in secondary, it is quite transitional. A manipulative may or may not be an option later on when they are expected to factor a trinomial. It may not be efficient, and so hopefully they're able to move beyond this in their thinking at some point. But it gives them a picture, a representational picture that frames their understanding and can be helpful. So the manipulative I'm going to look at is the mathies, and I think that I've mentioned that already. I'm going to go straight there. So typically when teachers are connecting a visual model to expanding or factoring trinomials, they'll ask students to make a rectangle. So we'll create a rectangle from the 2x squared plus 11x plus 12 that we've already seen. And I'm just going to finish that up in this Matthews program. One of the things that's really neat about this is that you can vary the length of the x tiles, and the y tiles should you use them, which gets rid of that really counterintuitive piece of the physical manipulatives where you can't, they definitely have a length and kids will measure them with rulers and say, well, how can this be x? So I really like that feature. Another thing that's really neat is it's fairly efficient. As long as you're working horizontally, you can just add in a rectangle representing their trinomial. Then one thing you can use the Matthews program for is to show how this is a direct extension of their multiplicative thinking from grade 5. And you can change the color of the tiles to show that. And there are the partial products. And it becomes obvious why you have to split the middle in a particular type of way. Some kids will see how this plays out algebraically, even without a visual model, even without manipulatives. But differentiation involves meeting everyone where they're at and moving them to a learning goal. One way to help with that is to take a look at the developmental continua and see how we can leverage those to bring all students on board. Thank you very much for attending the session today. I really hope this was useful, and I really hope that it interests you in taking a look back to elementary and middle to see where some of these concepts in secondary originate and how we can use those foundations to enhance student learning in secondary. Take care.